Hello everyone, I am Arshaan Sheikh and today we are going to talk about memory management in operating system. So memory management is vital for operating system efficiency and stability. It controls how memory is allocated, protected and utilized to boost system performance and prevent crashes. Now we'll understand memory hierarchy. So first we have the CPU registers, which are the fastest and smallest memory area, which is directly inside the CPU. Then we have the cache memory, in which we have multi-levels like the L1, L2, and L3 cache, which balances speed and size. Then we have the main memory, which is the RAM, in which we stores active programs and data which is slower than cache memory. And at last we have the secondary storage like hard drives and SSDs, which are slow but have large memory area to store. Now we will talk about the basic memory management or contiguous allocation. First we have the single partition, which is simple but waste memory as only one partition is used. Then we have the multi-partitions, in which fixed or variable sizes improves utilization but cause fragmentation. Then we what is fragmentation, which is internal waste space inside partitions and external leaves gaps outside. Then is compaction, which rearranges memory to reduce external fragmentation. Now we'll see about paging, which is fixed size memory division, pages and frames. So logical memory divide into pages, physical into frames. Then what is page table? So it maps logical pages to physical frames in the memory. And at last we'll have translation look-aside buffer, which is cache memory for quick page table, which access with 98% hit rate. Now we'll talk about the segmentation, which is logical memory organization. In this, we'll first talk about logical segments, which separates code, data, and stack for flexibility and clarity. Then we have segment tables, which map segments to physical addresses, enabling protection. And we have protection bits, which set the read, write, and execute permissions to prevent errors. Then we have segmentation faults, which is raised on accessing invalid memory segments or stoppings. Now we'll talk about memory allocation strategies. So what will be the strategies to allocate our memory? So first is the first fit method, in which we allocate first suitable block, which is fast but the memory can be wasted. The second method is the best fit method, in which we choose a small sufficient blocks which reduces fragmentation. So it is best fit method. Now we have the worst fit method, where we allocate large block may create leftover gaps. These are the memory allocation methods. Now we have the memory protection for security. First, we will talk about the base and limit registers. We define valid memory addresses range per process. Then we have the memory management unit, the hardware component translating and access and controlling the access of the memory is memory management unit. Then we have access control list, in which we specify permissions for different memory regions. Now, what is the summary and the future trends of the memory management? The efficient management, which is essential for system speed and reliability. Then we have technique trade-offs, which is choosing methods balances performance and complexity in the memory management. Mm, At last, we have the emerging technologies like non-volatile and persistent memory transform memory design. By this, we can enhance the skills in memory management. And here comes to the end. Thank you. If you like the video, please like, share, and subscribe.